Wow, that was fairly amazing. Hey, everyone. Yeah, I'm just very saddened that I'm not in the UK, so I'll have to miss out on those bits, but maybe some other time. I hope I can stop by in person at some point. It's really great to be here, see the amount of life in this community. Sounds like with that Christmas event, 2020 will be a year to remember for good reasons too. So um, with that, I believe I have the floor for the next hour and a half to 2 hours or so. Um, I couldn't possibly talk for that long on my own. So I really, really depend on everyone's participation here. Um, so if you have, rather, when you have questions, please pop them. Somehow I got myself into a view here where I can't see the chat. Let me see if I can get that up. But
if you hover your mouse
I can
over
keep
where
an
it
eye on
says
it,
you're
Mads.
sharing. Oh, sorry.
I found it.
Okay.
There we are.
I've got
so feel free.
YouTube and the chat up, so I don't mind keeping an eye on it for you.
Excellent. And yeah, so just all along as we talk, let's have questions or comments or anything and make this a conversation. That should be more fun for everyone. With that, let me jump right into it. I'm going to make the first part brief, and very soon we can switch into Visual Studio, and we can spend most of the time in there because that's all our favorite place to be. But I figured I'd just open with, since I'm a language designer and I have to sort of justify what I do, I wanted to just open with talking a little bit about how we think about designing C# and what kinds of principles are behind it. So a couple of years ago, in 2017, we actually put up a blog post that summarizes this, and you should feel free to go there and read the full story. But the essence of how we think about it really is that is three things. So the first one is we want to fairly aggressively evolve C# and innovate in C#. So you sort of have, when you have a good old programming language like C# that's been around for a few decades, you sort of have a couple of options as to how to move forward. Given that the programming landscape is changing all the time, both in terms of the kinds of challenges, the kinds of domains that you work in when you program, and also just in terms of programming language tech, like new things are being invented and so on. And so we really have a choice as to whether we want to, how aggressively we want to follow along with that, or even sometimes lead in that space. And we lean on the fairly aggressive end of that scale. You could certainly imagine, and some languages do sort of hang in the brake more, and that's really a choice. Either way, you sort of run some risks, right? If your language doesn't keep up with the challenges that developers face, then eventually, that won't be the language that you'll pick up for your next project. That it might be that you still have maintenance for years and so on, but it'll gradually maybe become a legacy language for the existing code. And on the other hand, if we keep adding new things to the language, then it'll become bigger and bigger. And it's a challenge for us, and that's sort of the path that we've chosen, because we do want C# to be a relevant language. We want it to be one that you want to choose next time around. And so the price of that is that the language grows. We can never take anything out, because then we break the code that you already have. And so it grows and grows. And even though we try our best to do it in a way that's coherent and in line with the spirit of the existing language and so on, it does get more complicated over time. It has some costs in terms of learning the whole language, keeping track of it all, and so on. And so there's another kind of risk there, that we get ourselves eventually to a point where C# becomes too unwieldy for people to pick up. So those are just sort of like those are the two extremes that we kind of have to navigate between. So we try our best there. The next thing is that C#, even it started out as pretty much a Windows app development language. It's really nowadays being used for pretty much anything. I mean, it's just, there's very few things that aren't being developed in C#. So taking the consequence of that, we don't want to focus our language design on things that primarily benefit a particular domain within that. We kind of have to focus on things that are generally useful to programming. So sometimes we do have some features that we add that we don't expect most people to use, that are sort of more niche. And that tends to be at the lower end of the programming language, where maybe you're interfacing with native code, or we're building sort of the innards of our frameworks. That's where a few good C# language features can be used by a few at the bottom, but they sort of benefit everyone on top by having better performance or better safety of the underlying layers. So that kind of counts as benefiting all C# developers as well. And then finally, there's a vast community, and of course, C# has undergone this evolution from being a closed technology like everything else at Microsoft when it at the time it was born, to being something that is very much developed in interaction with the community. It's an open source language implementation, open source there's design as well. We have a design process that lives in GitHub, and in a minute we can have a look at the GitHub site for it if you like. And so what used to be a communication with developers every 3 years or so, we would come out with a new version, we would announce it at a conference, it was already done and polished, and we would get some feedback that hopefully was good, but not always. Now we have a day by day, hour by hour communication with the community, and we can get that sort of corrective feedback, as well as many ideas that eventually become language features, sometimes developed by community members even. We just get that all along, which of course is the right way to do things. And at the same time, we then just have to be careful that that doesn't mean that we become a design by committee kind of language. So even as there's huge community participation, there's still fairly centralized decision-making on C#. There's a design team that, the C# language design team, that does make the final decisions on what C# should look like. And we try to do that in a very consensus-driven approach, and with people being on the language design team for a long time, so that we get a sense of coherence and of keeping the language together, if you will. Like, we try really hard to use the way that we work and the way that we make decisions to make it a good, a well-integrated product in and of itself. So there is some strong leadership there, which I think a lot of sometimes it's a little annoying to the community maybe, but we have to balance community influence with the orders of magnitude more users of C# that expect to see what feels like a very well centrally designed product. So that's essentially the philosophy there. And I was wondering if anybody had questions on how we work before we get into the techie details. I don't see anything on the chat so far.
And feel free.
Not on any of the chats yet.
When Mads asks that, it means you can come off mute and literally ask him a question if you like, or if not, then feel free to carry on.
Yeah, absolutely. Throw it at me. We have 2 hours, guys.
Go on, I'll go first with the question then.
Yes.
Do you have a view? In other words, are you pro or against stealing features from other languages because they seem like a good idea?
Oh, I'm very pro. I'm all for crime. We do it a lot, and other people do it to us. And I think that so I'm very much in favor of learning from each other. There's sort of like a programming language community, if you will. And we all of us doing programming languages today, we rest on the shoulders of giants in the past. And we're a field of study, even if we're we're also very embedded in the commercial sphere. We're a field of study that evolves, and where new ideas come out, and we don't try to hoard our own ideas and keep other people from adopting them. And we also don't hold back when it comes to really good ideas that we think should make it. We try, and so if you look at C#, there's been plenty of give and take over the years. Take a feature like async, though in the shape that it is, it started out in C#, and we did a lot of hard design work on that to get it to where it felt like it was the right thing for an imperative programming language. And lots of other languages, including now JavaScript, have pretty much just adopted that and say, hey, thanks, good work, we'll take that. And on the other hand, and we often get accused of stealing our features from F#. We put a lot of functionally inspired features into C# because we think they're the right thing to do for a cloud world, and we try to integrate them the best we can into an object-oriented setting. But we certainly don't invent them from scratch. Like, we do a lot of fitting it to the C# world, but I won't say that we necessarily steal them from F#. Many of those features are ones that have been in the functional community even from before F# was born as well. And that just goes to show that these ideas and these features, they just sort of permeate the membranes between the languages. And I think that's a good thing. I think that just benefits developers very much. Let's see, here's one in the chat. How do you maintain coherence in the language design? Despite its legacy and influences, C# seems distinctly C#. Is that a conscious effort? Yeah, it is very much a conscious effort. It's hard to quantify, like, what is exactly, when does something feel like C# and when doesn't it? And so the method we use here isn't very scientific. It's more about the people. It's more about ensuring we have continuity as well as renewal in the group of people who design C#. So there are a few people like me and a couple of others that have been on the C# language design team for well over a decade. So we try to address that through process, through like how we do things. And then, of course, there's plenty of feedback to tell us if we're wrong. So we'll typically find out if we do something and then a lot of people say, well, that's not very C# because, and they have good arguments. Well, we'll listen and we'll change. Yeah, great questions.
I've got, I don't know if you can hear me, might as well.
I can, yeah, go for it.
Oh, cool. Yeah, you mentioned that you didn't want to break things. As the language evolves, you don't want to break things that already exist for other developers. So there's sort of a backwards compatibility thing there. But I know there has been some very niche sort of things like the nullable reference types, which are kind of like, I know they don't break things, but do you see, like, when we get to, I don't know, C# 15, 20, and so on, more things like that start to happen and the language start to evolve, and it kind of does break things, but iteratively, if you like. Or
right, so that's
growing.
Yeah, and this whole, like, what does it mean not to break things, and, you know, when are you not breaking things? They're definitely, I mean, with 9 major versions of the languages now out, there are definitely more and more times when we look at something we want to do and we realize that it's going to break existing code in one way or another. So we keep running into this more and more as the language grows more mature, and more of these sort of the possible combinations of characters get used up by meaning. And so it is a challenge. With nullable reference types, we decided that that was worth a feature flag. In essence, you can turn it on and off, and therefore you don't get breakage. And also, when you turn it on, the kind of breakage you get is just that you get a warning. It's not that something will silently change its meaning or that you will get hard errors unless you ask for the warnings as errors and so on. So we decided, okay, it's worth that kind of switch because it's a big change. I think also, I mean, I don't think we will do that much. I don't like us getting to a place where we have several switches that determine which exact dialect of C# you're using. I do think that there are that we may be able to wriggle the not breaking rule a little more now that we're more and more solidly in the .NET Core camp, where there's a little more opportunity for renewal, if you will. We won't do it much, though. I mean, honestly, I think mostly we won't throw anything out of C#, and we won't change the meaning of anything in C#, except in very fringe scenarios where we think that's going to be okay.
Cool.
Mads, both of those are really interesting topics from a VB standpoint as well, from Visual Basic standpoint, because keeping everything like it's C# and also not breaking things is one of the reasons why they've sort of stuck feature-wise with VB now, because I think it's true that they looked at all of that from a VB community point of view, and the VB community was more inherently, we want the language to be stable rather than we want all these cutting edge features that are likely to break. At least backwards compatibility, I think, is the main thing, isn't it?
Well, for VB, it's true that we've essentially stopped adding new features to VB. It's not entirely true. We don't generally add new syntax to VB. So when C# adds something new, like in a little bit, you're going to see init only properties, then VB doesn't get that same syntax. They can't declare those same things, but we do evolve VB to be able to gracefully consume whenever C# gets new features like that. So you can sort of write your libraries in C#, and then VB users won't be stuck not being able to consume those libraries. But that said, I don't think the main thing for VB not adding new features is backwards compatibility so much as actually the VB community not really clamoring for new features. There's a feeling that having to learn and adjust to new features wasn't really worth it in the VB space. It is an older language. It is more feature rich to begin with, and there may be there seems to be more of a preference for stability in that community, and so it also gives us, an opportunity to differentiate there a little bit, where we have a stable language and we have one that's scoring at a different clip, at a C# at a more ambitious clip, and then of course there's F#, which is an entirely different thing again, and maybe another couple of notches up the bravery scale.
Yeah, I think there was something specific in VB that for them to add a new feature that C# had would have been a massive rewrite. And I think you're right. I think it's just they look at it and it wouldn't have been worth the massive rewrite to make it work. I forget what that was now. There was something specific that they couldn't do. But I'm guessing that happens when you see certainly F# develop a new feature. It might be, we really want that, but I'm guessing that there could be big rewrites under the hood to force it to happen.
That's sometimes the case. But it's not, big rewrites that we have to do. That's a cost, and it does factor into the decision process for sure. But oftentimes it isn't as bad as it used to be. We used to have the C# implementation be written in C++ and sort of split between compiling versus IDE support and so on. And as of the Roslyn rewrite of was it half a decade now since we shipped it, that's all entirely written in C# and is very well architectured, and it's a complex piece of code, but there are rarely things that are like, oh no, we did it all wrong. We have to structure everything. We have to refactor everything in order to do this feature. Not at that grand of a scale. Sometimes for a little subsystem, we're like, oh, we made some assumptions here. We have to kind of move some things over. But it's rare that there's this feature that just, oh, we have to redo everything. There was some of that with Nullable, because that was this whole concept that had to be threaded through everything. But it wasn't sort of like a fundamental architectural rewrite. So all I'm saying is that the compiler code base is has been very good to us in terms of adding new features. Part of when you see feature velocity go up in C#'s evolution is when Roslyn came out and we had a compiler that was much easier to adapt and evolve.
I got one. How willing are you to look at sort of new ideas that require new language runtime features, like the abstract interface methods? Is that something that now it's on the table, is something you look at more, or is it more that when a feature really needs it, then you look at it? Or how do you think about that?
No, we do look at that more. It used to be that we felt we couldn't touch the runtime at all. Between when we added generics in C#2 and for the rest of the time when we were targeting .NET Framework, which was a Windows technology, and the runtime was a Windows component, and just for a developer to make sure that their code could run on end machines was a deployment kind of nightmare. And so we felt that we couldn't really implement language semantics in the runtime in that whole period. And that actually cost us to make what I think in hindsight were there were decisions we had to make at the time, but I wish we had been able to do them differently, where some features were implemented entirely as compiler tricks rather than where they naturally belonged in the runtime. And I think an example of that is async, where we generate some very complicated state machines at compile time that are essentially completely rewrite the code that the developer wrote, and they're kind of opaque to the runtime. It doesn't have the opportunity for optimization and so on that it would have had if it had been charged with implementing the essentially coroutine-like behavior of async. I think we could have potentially done that completely differently and much better if we could have changed the runtime. So we are trying to learn from that, both to implement the features we want in the right place where the implementation belongs, and also to do features that we just couldn't do before because of runtime limitations. And we've done several features now, that big and small, that required runtime participation. And we have others envisioned, including some very big ones that we might get to talk about at the end today, that could potentially happen, but only if we tinker with the runtime itself. We're happy to do it now, and it really opens up more of the design space for us.
Speaking of tinkering with the runtime and also of stealing things from other languages, is there a likelihood you might ever go to things like hotspot optimization like they use in Java? And
yeah, I think
history-based optimizations.
Yeah, I think classically the Java stack and the .NET stack use different approaches to runtime optimization in the runtime, and I think there's definitely opportunity for more adaptive, more later just-in-time compilation or recompilation technologies in the runtime. That's not something I'm so involved in, but I think we don't have that's not a strong reason why that couldn't happen. We started out in different corners of how to do things, but that doesn't mean that we can't evolve. So yeah, I'd expect to see some of that.
Dado has sorry if I'm pronouncing that incorrectly, a question in there as well.
What's that?
Dado
oh, yes. Oh, yeah, sorry. I'm going to take that as well. At some point in the future, is there a chance of creating a trimmed version of C# that doesn't have legacy features? It's possible. I dream about it sometimes. Oh, if only we could get rid of this old thing, then life would be much simpler, and we could add some new features that occupy some of that same space. It may, it might happen someday. We have no plans to do it right now. It will probably be, it will be a flag to the compiler. You can also imagine, if you just want to not have those features available, you could also imagine it as a Roslyn analyzer that just flags certain features and says, nah, we're not using those here. So if the goal is more to have a given developer population, like in a company or something, limit themselves to a certain set of features, then that could be done more locally. I don't know that we have any desire to centrally curate sort of like a modern C#. And we would have to keep doing it over, and we have to call as we add new features, we'd have to sort of have a calling process at the other end that relegates more and more features to the legacy bucket. And I don't know that I don't know that we have interest in doing that right now. But I mean, well, I certainly feel the urge to do it, but I don't think it makes enough business sense to do it centrally.
I don't know what the words are. They're escaping me. But is there like an SLA with the C# language? Does it get support like .NET itself does with LTAs and things like that, or is it intertwined with the .NET releases? And how does that work?
The language itself is really it's not a software artifact, right? So it doesn't have anything like that. Compiler is, is used as part of Visual Studio. So it's affected by different other like support promises that we have, the .NET one, the Visual Studio one, and how that all exactly interacts, I'm not the right person to ask. I'm lucky that I'm in charge of an artifact that's entirely ephemeral. Nobody ever, C# itself is not a product in that sense. So I get to ignore that kind of question.
Fair enough. Anybody else have any questions?
Right.
One last one from me. So now that Rosalind's been sort of exposed to more people with things like analyzers and source generators, has there been much thought about like the more the language changes, the more those things break, as some of the pattern matching might need to then be updated, or is that just a consequence of some of those features?
Yeah, I mean, certainly when you depend on the compiler's model of the language to represent code and manipulate code with an analyzer, with code fixers, with source generators, and so on, then you're sort of taking it upon yourself to try to write those in a way that is resilient to language changes, or take on the burden of updating them when the language changes. That is, we tried to make good object models for representing code in Roslyn, and we try to make them in such a way that you can speak in general terms whenever that makes sense, and you can depend on fewer details. But at the end of the day, when you do that kind of thing, you're building language tooling in a sense, and language tooling has to accommodate the evolving of the language itself to some degree. That's sort of something you sign up to in those cases. And we would never, knock on wood, we would never like not add something to the language because it would break analyzers. Like we would try to do it in a way that has minimal impact on them, but if we want to add a language feature, we add the language feature. That's like, there's millions of language users, and there's maybe hundreds of analyzer writers, or thousands maybe if we're lucky. So that's just an order of magnitude difference there, that language comes first. All right, want to go do some code?
Yes, please.
Yes, okay, let me see. Yeah, let's start with this one here. So C#9 just came out a couple of weeks ago. And what I have here is still preview software, even though there's an official version, just because I like to live on the edge, and it's the only VS I ever run is the internal preview that we get at Microsoft. So so if anything fails here, that's probably the reason. It's not because I'm a lousy presenter or anything like that. So let's start working down the list of some of the features that we've added in C#9. So first of all, we sort of have a running. There's a thing about C# that it's fairly old, and programming languages back then tended to be a little verbose, and there are many places where we've done something and now you can ask yourself, why does it need all that boilerplate syntax exactly? Could we make things more terse, more simple, more clear? And we sort of have a running theme of identifying some of those things and making them better in C#. Essentially introducing a shorter way of saying the same thing. And the main one of those in C#9 is that is this thing that we've all gotten used to, that the main program lives inside of a method that lives inside of a class, and the compiler magically finds it there. And everyone who comes to C# for the first time has to learn to write all that goop around it. And it's sort of magically, before anybody tells them what a class is, they still have to do that. Everyone who looks at a simple program has to kind of mentally push that aside and look for the statements that are actually the program. And we're like, let's not force people to do that. Let's just allow you to delete all that enclosing stuff and put your program, your main program, at the top level of your file. So now you can just write statements in a source file of your choosing in your project. You just write some statements, and that's your main program. Right. You do it in 2, we're going to complain because we don't know which order to do it, but you do it in 1, and that's your main program. So I can just do this. And in fact, that's how I'm going to write my programs from now on, because I think it's much clearer and much easier to read. Now it might be, so what about my args, and what about async, and so on? And so we made it so that this has pretty much like 98.7% the same expressiveness as the old way. You rarely have to go back to the old way. So if you want to talk about args, you could, we actually put a magic variable in scope called args. That's what everybody calls that parameter anyway, since that's what the template puts in. So you can still talk about the args. They're just magic now. If you want to do something async, which we added the capability for a couple of versions back, you can just await task.delay 1,000 here, and we'll just discover that you're using await in your main program, and we'll make it an asynchronous entry point and make sure to not stop the program before the end of these statements has been reached. Now you don't have to think about, oh, should I, do I have to change the signature of my main program to return a task instead of void and call it async and all that stuff. It's just there. So things become a lot more approachable to start with. Any questions on that? I'm going to delete the async stuff and this stuff here.
Is that true also for like console applications that might want to return an int as a return code or something? Will that automatically?
Yes, it is. Yeah, I forgot to mention that. Yeah, you can totally just do that, and it will insert int instead of void, or task of int instead of task, as appropriate, as sort of the result of the main method, if you will. You can sort of think of it as it really writes the right main method around this, if that's how you want to think about it as an old-fashioned C# programmer. So yeah, you get to do all these things still. Let's see. How does the compiler work out the entry point in multi-file applications? Well, it just sees if there's more than one file that has statements at the top, it'll just give you an error. So, and if there's only one, then that's the one. You don't have to name it specially. There's no like, this is the main program over here. The compiler just sees that there's one and it picks that one. So no reason to make things complicated. There's something that's interesting about the what used to be a local function here. This function declaration sat inside of the main method when I started in the program here. And the way that we think about it, the way that we made it work, is that this is still a local function to the top level program. It's not somehow a new kind of top level method that I can call from elsewhere. Like I can't call it from inside of my person class here, for instance. That might also be a very cool feature at some point, that you can declare functions at the top instead of them having to live inside our classes. We're not sure about that yet. It's a potential feature for the future. And we designed it we made sure that the lookup rules around these local functions in top-level programs are such, and the error modes are such that we left space to fit that in later if we want to. So if we want that feature one day, we can, but it's not. We don't have it today. This local function is only available inside of the program portion of the top-level statements here in themselves for now. All right. Okay. So next thing, one of the things I mentioned before that we sort of took a lot of we learned a lot from functional programming. Actually, through most of C#'s life, we've been taking in ideas from functional programming. And one of the things that's been really good for us in recent years that we use a lot in the Roslyn code base ourselves is immutability. So the fact that you can't change something is actually, sometimes a feature. And that's something that you do. Sometimes you want your object models, your data types to not be mutable. That gives you various benefits, such as being resilient to multi-threading, for instance. You're not at risk for suffering from shared mutable state when your state isn't mutable. There's just no mutable state, so it doesn't matter if it's shared. And in Roslyn, for instance, we build all our syntax trees and so on immutably. That means we can freely hand them out to multiple clients, and nobody's going to mess up the representation of the code. Nobody's going to stump on each other. But it does mean that there are certain different patterns that you want to use around programming with immutable data. You can't do the same things. And so how do you do the things that involve changing? And so first we're going to look at the immutability itself and how we support that better in C#9, and then we're going to talk about supporting some of the patterns around that. Let me see, and some questions actually. Keep functional programming, sure. Over the last several years, there have been proposals for immutable local variables. Seems very useful. Are there solid arguments against this, which explain why it's not being taken up? So why don't we have so we still don't support immutable local variables. So the local variable, you can't say something like, here's a local variable. You can't say something like read-only var. We keep almost allowing it, but it almost becomes like a thing that so we haven't landed on doing it yet. It's a lot of extra syntax just to make sure that you yourself don't accidentally change it a few lines further down. So it feels like one of the things that if people feel compelled to use it, and their source code just gets bigger, even though they were probably doing fine. And so, yeah, is read-only var an oxymoron? That's a great question, because one of the ways that we thought about dealing with that was maybe we should have a replacement for var that you could say val or something instead, and now it's read-only. So now it doesn't make the code longer. It's still, we haven't gotten there yet. Now we have to think about, what about parameters? Should they also be able to be read-only? And so it's, we might get there one day. It would certainly it would certainly fit into the theme of immutability. But that's not the place we've chosen to set in C#9. I won't rule it out in the future. I'm just saying we haven't gotten there yet. We keep not quite landing at where it feels like it's unquestionably an improvement for C#. One thing though is that at the object level, like for objects themselves, if you let me start in a different corner. There's different ways, since C#3, there are different ways that you can think about how your object should be created. And so, starting out with C#1, you write a constructor, you give the constructor some arguments, and they get filled into the object. And in C#3, we added this other approach, which is using object initializers instead, or together with constructor calls. And the reason for that is that sometimes the constructor thing just becomes a whole lot of bookkeeping. Right? If you want to make some of it got a little better with optional parameters, which we finally got in C#4, but still there's sort of a lot you have to write, especially when you have class hierarchies like we do down here. Constructors need to be chained. Whenever a subtle thing changes, you have to make sure you thread all the changes through that whole inheritance hierarchy. The parameter lists grow longer and longer the further down you get, and so on. And there's this alternative, which is, well, just declare the properties and use an object initializer to initialize them. You don't get everything. You don't get like mandatory properties. You can't require them. But on the other hand, it makes for a very simple way of writing your object models and a very sort of also elegant way of creating your objects. And so there are places where people actually mandate this approach over constructors, and they're certainly good to have side by side. But the problem is that what object initializers really do is that you create the object first and then they mutate the object. So they rely heavily on mutation. So in previous C#, I can certainly make an immutable data model by removing the setters. Now these properties are immutable, and that's great. But now I can't use object initializers anymore. So you've been forced to, once you take the immutable step, you've also been forced to take the I use constructors step to construct your objects. And that's kind of annoying. Of course, so if you do want to have an immutable object model, that's something that we want to support in C#9. And so we came up with this version of the setter that's called an initter. So an init accessor instead of a set accessor. I'm using them here in auto properties, but you can also declare your own init accessor, just like you can declare a set accessor to have mutability. It's really just a variant of the set accessor with a different name. And when you do that, you can see that the object initializer is allowed again, but what it means is you can only mutate the properties while you're in the object initializer. And after that time, I can't go up to the last name, say, and change it to my other great colleague, Hanselman here. At this point, after the end curly here, because I used init instead of set, the property is locked and you can't mutate it anymore. So this gives us, all it gives us really is the ability to marry object initializer style with immutable style.
Sorry, Mads, you've got another question in the chat.
All right.
It's actually, Peter's written it down. Somebody on YouTube has also mentioned, why not const? Is that because it's read-only from the outside, but writable internally still?
Const in C# has a different meaning. It refers to actually compile time constant things. So we even have grammatically speaking, there's a subset of expressions in C# that can be computed at compile time. They fully computed at compile time. And that's what it takes to be const in C#. So we feel like the const keyword is wrong for something that is merely read-only, but is computed at runtime. That's why we didn't. That's why we don't feel like that's the right way to go. I really wish there was some Go feature for auto properties, just so I can write get set go. Well, yeah, if you can come up with a really useful meaning for that, then we can discuss it.
I'm on it. I'll get back to you.
Thank you. So that's init-only properties, and that's all they do. Any property can be written with an initter instead of a setter, and now the property is mutable, or the setter of it is callable only during object initializers. So that sort of takes care of that aspect of immutability. It works well with object initializers. Now, if there are no more questions on that bit, going once, going twice, Ready, set, go.
Sorry, I was just too late getting unmuted, was I? I was merely going to wonder why we need another keyword for a set accessor. Would it have been just as acceptable to say inside the curly braces of an initter, you are equivalent to being inside the private part of the class and therefore able to access something that is private? I'm not sure that I see how they are different.
Oh, well, it's not so much about, I mean, allowing people to access private things inside of an object initializer. Is that what you mean?
Effectively, that may be constrained only to properties and fields. I don't know, because I haven't thought it through.
Right.
I just wondering
between that and
limit accessor.
Right. There's a problem with that, which is primarily that this would allow, so people who already wrote classes today, now we're getting to that compatibility thing again. People who wrote classes today, they have certain expectations about what can be done to those objects from the outside. And they use those expectations to maintain invariance about what the object can look like. There are only these ways in which it can be poked at. And so if we start allowing something new like that, oh, you can get at the private stuff from here now, then we're breaking those assumptions and potentially undermining the data modeling that people have been doing in the past. That actually also, that applies interestingly to read-only fields. When you have an initter, so when you have a setter, if you have a read-only field inside of a class here, read-only string s, then you know, it can, up until C#9, it can only be mutated by, you know, directly initializing it or from a constructor body. Right. After that, it freezes in place. We actually allow you from inside an initter. That one way that is different from a setter is we allow you to mutate read-only fields from in here, because we know that this is happening only during initialization time. So we're saying that that is going to be okay. And so this would be allowed, except it's an auto property, so I would have to implement the getter also to do it right. But this would be allowed. But but exposing the read-only fields directly, even if they were public, then allowing them to be assigned inside of the object initializer would be wrong, because again, it would allow people to do something that they couldn't do before to existing classes. We have to protect the invariants that people have already built into their classes pre this feature. So we had a similar conversation about, very similar to what, that's why I'm bringing it up, very similar to what you were saying. So private and read-only things we can't sort of after the fact go and expose those in more places. Down here it's okay, because somebody, the author of the class, said, I am the one who's changing this to init and assigning to my read-only field, and that's okay. So there it's okay to allow read-only fields to be mutated in a new way, but not in client code. Make sense?
Yes, thank you.
Awesome.
Can I just throw one more thing out there that's also not very well thought out? The idea, so you've got these init setters that run up until the end of initialization. Have you thought about the idea of perhaps making the end of initialization determined by the developer, so that you would enable some sort of builder pattern kind of thing? So maybe making, I'm trying to think of other terminology, sort of freezable perhaps, where you can set the read-only properties until you've finished building, but perhaps distribute that build process across multiple steps. I mean, I've not thought that through very well, but
no, but I get exactly what you're saying. Like, could you maybe allow for statements after here to still mutate the object, and then at some point say, now it's done?
Yeah, that's basically the idea.
Yeah, and we're like, we've talked about that a little bit as well. The thing that's really nice about the object initializers is that they're limited in various ways while the object initialize is being executed, you can't actually observe the new object yet, right? So there's no way to talk about the this that has just been created. And so you don't get into weird things where you're observing the object in an unfinished state while it's being initialized. And I'm not saying that would be bad necessarily. It's just something that we would really have to think through. Like, are we sure that we're not creating something monstrous? And we have to be sure that we certainly have to be sure that we don't share a reference to the object out to others who think they're observing it in its final state while it's still being initialized. So there's that kind of concern that we would have to find solutions to that before we would consider going down that path. And so just limiting it to object initializers, it takes all that away, because there's no reference to the new object that you could accidentally give to someone else and they would observe it before it was done.
Yep, that seems reasonable.
Yeah, but great idea. And actually, I think at the runtime level, these do turn into assignments. These are assignments, and we just track, the compiler tracks that they're still okay. And there's a way that this turns into assignments. It turns into C# code that you couldn't have written yourself because we don't have the feature you mentioned. Okay. Anyone else on init-only properties? I think we've been going for almost an hour now. So I think that, or longer if you count all the initial stuff, we should maybe give 10 minutes at this point to people to get a little bio break.
Do you feel free to take the time now before we start again?
Advent of Code starts tomorrow. We've got an Advent of Code channel on the Technotium Slack.
Oh, right. Awesome. I've not even seen that. Do go and join that then.
Has anyone managed to do the whole Advent of Code yet?
I've never managed to do the first day. Despite
I managed to get to day 16 last year before going on holiday, which was very disappointing.
I've only ever got to 13. And then I forgot to do the rest.
I think it's still open. You can still go back and finish last year's.
Oh.
For those people that don't know, Andrew, do you want to tell us what that is? Oh, is Andrew gone again?
No, I'm here. Sorry, I'm making dinner at the same time.
Sorry.
Code is a sort of daily coding challenge throughout Advent. So for first 24 days of December. And you can find it by Googling Advent of Code, because I don't even know what the web address is. But it's really good, and they're always really interesting challenges, and they sort of get progressively more challenging, and it's a good community spirit, because people are also doing the same thing, and people are doing it in different languages and applying different constraints to themselves and things like that. So it's good fun.
I don't know if you mentioned, Pete, but Kev's also put in that it's the .NET Chef Tech Pub quiz tomorrow night.
That will be fantastic. I'm trying to think what I'm doing tomorrow night. I'm quite busy.
I spent far too long actually putting it together. I thought it was going to take a night to put it together, and it took me over a week. So it'll be good. We have prizes too.
Oh, nice. It's good to see you, Kev. It's been ages.
I know, I've been busy.
Yeah. Nice t-shirt.
Thanks. I think every time I see you, you've got one of these t-shirts on as well. So.
That's true. I am waiting. I saw Stephen Pears had tweeted out that his had arrived. I must say I was very jealous.
Yeah, it's perfectly. Looking forward to wearing that tomorrow.
Hopefully mine will arrive soon. I've got Jess to thank for mine, really. The amount of work that she put into the .NET Knots Hacktoberfest stuff was incredible, really. I contributed a little bit, but most of that work was Jess's. So
I was going to say, it's the contributors, it's not me. I just have to answer questions. That's easy enough.
Oh, you set everything up, Jess. It was fantastic. Wouldn't have been able to do it without you. So, and hopefully that'll be coming soon. I think I need to get you some details to be able to switch over the domain.
Yep, it should be going live in January, just before our next event. So, with luck,
we will get to that. And thanks to the community for getting involved and helping us hack together our new website. As it happens, the terms and conditions for the Cloud Skills Challenge, Adam wants to put them on the website as well. So we probably need to put those on the old one for now. So I'll get you those, Jess.
Cheers.
Just give you some more work to do.
I don't have enough to do. It's fine.
No. I love the fact that Philip Sutton is on his exercise bike while watching it. That is perfect. I really should do that because, well, you can tell that I'm not on my exercise bike enough.
It's how he powers his machine.
Sorry, what was that?
Sorry, Jess, you go.
I was just saying it's how he powers his machine.
I was going to say you could charge a few of your Raspberry Pis like that, Pete.
You know, that's not a bad idea. I like it. I really should do it. I know some people have got like standing desks with treadmills underneath them. Has Julie Lerman got something like that?
I think Steve Smith has.
Who has?
Steve Smith, Ardalis.
Ah, yeah, it might be him then. I'm not sure.
His videos, and he was sort of strolling along as he was talking, and
yeah. I think that I don't go to the gym anymore, and again, that's evident. But when I did used to go, I used to watch tutorial videos on my phone while I was at the gym on anything like that. It worked quite well, actually. But I don't know how much coding you'd get done if you were walking along. I think you'd probably end up mashing the keyboard more often than you would doing any decent coding. I don't know. Maybe it just takes practice.
I think that was the reason I never ended up doing it. I was very intrigued by it at one point, but the idea of the number of typos I would be making while strolling along would be too grievous.
Yeah, it's true.
I think I'd be more concerned with the damage to my face. I'm not sure I could walk and type and keep my balance all at the same time.
That might be true.
I do wish I could do something more productive than listening to podcasts while running, mind you. It'd be awesome to be able to do something a bit more productive. But I don't know. Catching up on .NET Rocks is probably good enough. Mads, what's the community like where you are? Are there many meetups and how they coped?
I think there's a fair number of meetups going on locally here as well, and all over the US. I've been to quite a few of them. I haven't actually been to any local ones now that you mention it. I guess this has been a good opportunity to go elsewhere. so I haven't done any around here or in Washington State, but it seems that many communities just either very quickly were able to change over to virtual, or gradually have picked it up after realizing that, you know, this was for the long haul. So, and I've talked to some that are thinking to maybe keep it up with more virtual events, even when we can get back together physically, you know, maybe every other event or something, because it gives different opportunities. It means if people can participate, sometimes it's nice to be able to go out and get that beer and that pizza, and sometimes it's nice to not have to. And for speakers, it means that, you know, apart from time zones, the physical distance is less of a problem. So.
Yeah, it's certainly something that me and Jess and a few of the other meetup organizers, and I know a few people in the MVP community have thought about this. And I think we still will do the virtual side of things, but I mean, there's if you look at it purely from a sponsorship point of view, nearly all of the meetups will be sponsored partly, if not all, by recruiters. And if people aren't coming physically to the meetup, that limits the amount of return, let's say, that sponsor can get back when they're not actually there. So there is a downside in that respect, but you are 100% correct in that, you know, the chances of us actually snagging you in person at one of our events would take quite a lot of organization. nearly always the problem is getting enough people to come along. But with a speaker such as yourself, we don't really have that problem. We would have enough people. But of course, we aren't 5 minutes from London, which is most likely where you would be if you're in the UK. We're 1.5, 2 hours. So it's not inconsequential the amount of time you'd have to spend to come to a meetup like ours. So.
Yeah, but I can understand how hybrid events would be difficult. You'd have to sort of alternate between fully in person and fully virtual is probably the better way to go. But yeah, everyone will find their own approach.
Yeah.
Once we're out of this weirdness.
Whenever that is. I mean, we don't plan on going back to in person until probably the middle of next year, if longer. And that was pretty much always the case. So it was always going to be at least March, but I don't see anything much changing, mainly from a culpability point of view, because often we're in other people's premises. And one of them is a recruiter and another one is a consultancy company, and they're not going to want a whole heap of the random public coming in and possibly infecting people. There may be an insurance issue with that as well. So chances of us actually starting to be in person again in the near future are limited.
Yeah. All right. Well, we have an event going, and it looks like people are popping back up. So let's leave the grisly world of the pandemic behind and dive into wonderful, colorful code. So I'm going to switch features a little bit here and sort of go to the next question around immutability, which is, okay, so now you've given me immutability in C#. What can I do with it? Like I have this squiggly line here because I want something to change over time. If I can't do it this way, then how can I do it? And that kind of goes into how do you do immutable coding with immutable data, and how should C# support those patterns? And this essentially, so let me comment this out for a second. This essentially comes down to when you use immutability to represent data, you're sort of you stop looking at things in a classic object-oriented way where the object is strongly representative of a real-world entity. Now you have to look at the objects more like values. They're like a snapshot in time of what that thing looks like at a given point in time. So you go from object-oriented to value-oriented in a sense, but you still want all your nice other object-oriented features like inheritance and virtual methods. I don't have one here, but you'd want that to still be able to have that as you model your data. But you want to, in other ways, you want to take a much more value-oriented view on that. And what that means pertains both to how you mutate, how you, what equality means and things like that. So we're like, how do we support value-oriented programming in C# when it sort of goes against all the defaults, if you will, and it's very heavyweight. We've done it with Roslyn and we've felt the pain, and it's very heavyweight to change semantics of a given object or given class to be value-oriented instead of object-oriented. You have to flip all the defaults. So could we do that for you with a language feature? And the answer to that is records. So there's a special kind of class you can declare. You say record instead of class. And we'll do it here as well. And now what it essentially means is I'm still declaring a class. Everything else is the same, but we get some extra capabilities on top of what you can normally do with a class. So that means that the meaning of these member declarations hasn't changed. It's still an inheritance hierarchy. I could still have virtual methods and so on. But I get value-oriented behavior. And that means various different things. The first thing is probably actually the least important, but it's very nice, is that instead of, I actually get a tailored toString method. So we overwrite the toString. So now instead of doing this, I could say write line of the person and get them written out with a nice, let's see if I can compile and run here with a nice compiler generated toString. So there you go. You can see it's a person and what its values are and so on. But the next thing you get is support for what we call non-destructive mutation, the answer to what to do instead of this line here. You want to create a new object. So when things change, you want to create a new object that is exactly like the old object, but with one or two things changed. And so we have a new expression in C# called a with expression. So instead of saying this, I can say var other person. So I'm creating a new person object that's like the first one, but with the last name being Hanselman, right? So this would not, so we want to represent a point in time where Scott Hunter changed his name to Scott Hanselman. Then we could represent the new state as a new object. We can actually get rid of the display thing here. So we have all the code on one screen, almost. We get a new object that's like the old one, but with the last name changed. So if we write that one out, other person, we should get both objects existing at the same time and with similar state, except for what we explicitly asked to have changed. And you'll notice that this is actually, this bit of the with expression here is actually an object initializer, right? I can put other things in there. I can put multiple properties and assign them here. I'm creating a new object. Instead of creating it from scratch by calling a constructor, I'm creating a new object by essentially cloning the old one and then mutating it according to the object initializer. Okay. So might be interesting to see obviously it was a mistake and Scott Hunter want to be called Scott Hunter again. I could create yet another object with another with expression saying other person with last name equals Hunter. And now we can ask ourselves, well, what about equality now? If we write out the equality of the person, let's just do a little interpolated string here. If we say equals, this is object.equals of person and original person, then in an ordinary object, that would be false, right? Because equality is reference equality. But what we really want is a notion of value equality. When are two values the same? And for comparison, we can just let's just copy that line and try to look at the. Hang on.
But do you mean to leave the space after Hunter in the original person?
No, I really did not. But that would give us a demonstration of something else, which is I'm not really very good at coding. So let's try this. So there's equality and there's reference equality, and let's try to apply both to these two objects. And what you see is that their equality has been overridden to say that they are indeed the same value. They have the same, and so value equality essentially meaning applying equality recursively to the state of the object. But they're of course new objects that have been created, so the reference equality is not the same. So that's what value equality means.
I'm sorry to interrupt. Do we automatically get an operator double equals for it?
Yes. So very good question. So not only do we override the object.equals, which causes this to work, but we also provide an overload for equal, and we actually also implement equatable of the type. So all the all the equalities are automatically implemented on the on a record class.
And you must use hash code as well. You just have to.
And, yeah, and then we do get hash code as well. And so you can see that the equals also does the right thing. So that raises some questions about, okay, what is it? What is this equality? How does it work? And we sort of took our guidance here from the place in C#, well, there are a couple of places, but the original place that already has value equality in C#, which is structs. They're already, they're actually both capable of cloning themselves, like we're essentially doing here, but they also have value equality already. If you compare two struct values, they will compare equal on each of the fields of the struct. And so we said, okay, we do it field by field, just like structs, because then we have a consistent notion of value equality across across the language. And that's actually also how we do equality on anonymous types, if anyone's using those. So it all works out, that it's the same value equality. There's something interesting though, if we, let's say that we created the person, not as a person, but as a student. But
sorry, Mads, to interrupt
you.
You've got a question from Steve on the chat as well.
Oh, great. Hi, Matt. Interested in your thinking behind basing records on classes versus basing on structs. And are there any plans for equivalent syntactic sugar being sprinkled on structs, like single line position? Some of what you're mentioning here I haven't shown yet. The short answer, Steve, is that in C#10 we are currently on track to also allow structs to be records. Structs already are able to copy themselves, and they're already able to compare themselves by value. But some of the other benefits of records that I'm about to show, you don't get by default an existing struct, and so we would like you to be able to opt into those by saying record. Actually, the equals implementation and the IEquatable implementation and so on would come on as well through that. Thanks. So that's not in C#9, but that's part of what we're planning for C#10.
Mads,
yep.
with that keyword, do you get a whole in-memory copy of that object just with the change made, or do you get something with a pointer to the original values just with a bit of memory allocated for the change? How does that work?
That's a really good question. It is a full copy. And so you have to be aware that when you use the with expression, you are allocating a new object and you're copying the contents, the full contents of the old one into the new one. So it's not free, it requires a bit of allocation and it has those assignment costs to it. We don't even optimize, so we copy even the last name over, even though it's just about to get mutated. And the reason for that is how this copying actually is implemented, because and I can probably actually let me show this next example, and that kind of explains how the copying is done, how the compiler does it. So no, this is great. Let's say that we are creating a new student instead of a new person here, and we can even give it a meaningful ID, like 1. This is the first student. So, or the second. Now we're actually creating a student object, not a person object. So it's a derived class, a derived record class. But the compiler only knows that it's a student or it's a person from here on out. So we're applying the with expression and the equality and everything to something that's statically typed as person. Now let's see how the program deals with that. It's now, the toString does the right thing. It's virtual. It prints out the ID as well and the fact that they're students. Equality is still true. This actually doesn't prove the point as much, but but the equality actually compares things at their runtime type. So it makes sure that, it checks that they're both students and it compares everything that is involved in being a student. Equality essentially is a virtual method, which you also know from object.equals that it is. But moreover, if you think about what the with expression did, it actually also figured out to create a new student. It didn't just copy what the compiler could see was there at the point of the with expression. It copied the full object and its full type, and everything that was hidden by subtyping at that point in the code. And so essentially the cloning that happens for the purpose of the with expression is virtual as well. And it is indeed implemented by a compiler implemented virtual method on the records themselves that gets overridden by derived types. The cloning itself does that. So that's what gets called when you call the with expression. You call the object's actual cloning to copy the full thing, then apply the object initializer on top to get the new result. Does that make sense? So it's inheritance proof, if you will. Both the value-based behavior, getting the value-based behavior and the inheritance to work well together. That was really sort of the main challenge of this feature. And this seems to work quite well. It means that you can still have your object hierarchies. You don't have to think differently about how to model the data. You only think differently about how you mutate it.
Yeah, it sort of breaks my brain that they are equal to each other. Because, if that was two different strings with two different values and you did an equals, I'm guessing they would come out differently. But is that the value versus reference type argument, or what is that?
That makes them equal?
Yeah, because they're equal because they're two the same type, but the values inside them aren't equal, of course. So
well, the values inside them are equal because I changed the I changed the name back. So all the values inside are equal. So what I printed out was not the two objects that were being compared. I'm sorry, that was a bit confusing in the example.
That's probably just me. I missed a bit.
Yeah, that confused me as well.
So I create another person again here, which changes it back to the original. So it has the same values inside, but it's a new object.
Oh, that's interesting still. So it's been mutated twice, but of course it's been mutated theoretically back to its same state. But
yeah, non-destructively. So it has the same state, different object identity. Equality picks up on them being the same.
Okay, interesting. Thank you. Sorry.
You've got a question from Michael in the chat. Sorry.
Yes. What would happen if you cloned across the types? Would it be error, i.e. student to person, or the other way around? You can't. The cloning is inherently built into the compiler generated code can only produce a clone of the same type. If I so cloning won't cloning will always produce something that at runtime has the same type. However, and the static type of the with expression is the same as the static type of the left operand here. However, if you compare with equals two things that aren't the same type, but maybe related in a hierarchy, then, and they're records, then the equals will say no, they're not the same because they don't have the same type. More specifically, we don't actually, there's a little more subtlety here, is that we don't compare the types themselves of the objects. We have another virtual property in there that computes the type of object, and then we compare the result of that. And that means if you want to change when two things are comparable to each other of the same type enough that the equality will compare them, you can do so with you can overwrite that property yourself, but that's sort of getting into the weeds.
Can I just ask a quick one? I'm sorry if this is a bit early and you're already going to cover this, but records can have properties that are records themselves. How does the with work with that if you wanted to say mutate a property on a property at the second level of indirection?
Right. So then it gets a little more involved because the one of the things that records inherited from structs is that their equality and their cloning is shallow, right? So we do clone the object itself, and we copy all its values over with ordinary assignment. So that means we don't recursively copy the whole object. We don't do a deep clone, and we don't do deep. Well, equality is a little more recursive, I guess. And that means that there are some patterns that still get a little gnarly. We still have to reach into the old object. If you're doing recursive things in your with expression here, you have to reach into the old object through a variable and get things out. That's something that's a little clunky with the pattern as it is, and we may have to come up with, we may try to think about ways to make that more expressible. Like, how do I reach into a nested record and change that as well? Because then I have to first ask for it from the old object, then change it, then put it back in, all as part of this expression in the object initializer. So that's something that, you know, gets a little more clunky at that point. Yeah.
Yeah, I mean, it'd be quite nice in the future to be able to do something like person with address.country equals Germany in that kind of form, rather than having to say with address equals person.address with country equals Germany, which doesn't seem the kind of thing you have to do at the moment.
Yeah, so I think that the kind of feature we're looking for is maybe one where you can dot on the left-hand side of the equals and actually change things deeper down. If they're all records, if they're all clonable all the way down.
Yeah, that'd be quite nice.
So it's that kind of thing that we'd be looking at. Yeah, we haven't really worked on it enough to figure out all the details there. But I think that would probably be the kind of feature. There's a question: what would happen if line 10 was student other person? Well, let's try it. You get an error because this has the static type person. The static type coming in is person, so the static type coming out is person. So the compiler just says you can't do that. Of course, if you really want to, you can cast it. So we could cast the whole thing to student and then get a runtime check of the type. But it's no different than other typing in the language.
I think he's corrected himself, Alan, there to say person, so strongly typing to person rather than leaving it as var.
Oh, I see what you say. Okay.
Yeah, but I think that's what Alan meant. I think there was a typo above.
Yep. Let me get back out, and then again, let's hover on the var here and see what it says. It says that it's a person. So what happens is nothing. It means the same thing, because because the static type of the right-hand side is person. The type inferred for var would be person. So this means the same thing as putting the var.
What's your view on that? Because that's almost like a perennial argument of, should we be writing the static type instead of var, or should everyone just use var? Or what's your thoughts on that?
It's a religious war, and I don't want to wade into it. I will tell you that I am myself a var preferer, as you can see in my code. I think that whenever you have code that is fairly obvious, then var is fine. You don't necessarily need to exactly track the static type explicitly in your source code. But on the other hand, I've definitely seen many examples where var leaves too much for the developer that's reading the code to figure out. Now you can always, as long as you're in the tool, you can always hover and see what the type is. And but when you feel like you have to do that a lot, then you probably shouldn't have used var in the first place. You should probably just put the type in.
We're triggering people in the comments as well. Look,
make love, not var. Yeah. I love it.
I like the var because it makes it look neater. So if everything's var, then the variable name is immediately after that, and it's in a line. So I mean, that's a very, very rubbish reason for liking it. But
well, and I guess you could use
3 letters, Pete, and then there you go. Problem
solved. Always have 3-letter type names.
Yeah. Oh, we could just go back to the VB days of putting a 3-letter version of the type just before the variable name, and that solves everything, doesn't it? BTN for button and everything,
The one other thing that's sort of like the benefit and the danger of var is that when you change something elsewhere in the code, that it means the new types just flow through. And if they don't give errors, then things just silently pick up new types going, through that flow of code, which can be dangerous in the sense that, well, that means the same code just now means something else. But on the other hand, it means you don't have to go through and update everything sort of, wasting your time updating all those type annotations.
I'm assuming you can write Roslyn analyzers to trap that as well, because stuff that might work, even conversions from int to I don't know, long or double or something like that will just work. But it might be that you don't want that to happen in your code. So I guess you can write a Roslyn analyzer that prevents that somewhere. Not that I've ever done it, but I'm guessing you can.
There are code styles in Visual Studio that use Roslyn analyzers under the hood. And you can set it to, I prefer var, or I would rather not have var, and you can set severities and everything. So
yeah, perfect. Thank you.
Yeah.
And yeah, in the chat, let's not talk about tabs and spaces.
Yes, on that topic, no, I won't go there. Okay, were there any more questions in chat? I don't think. If there were, then shout it out.
Did we get do types of all properties on a record have to be immutable types? Did we get that one?
Oh, I didn't see that one. Sorry. No, they don't. They can be anything. And in fact, actually, we don't even force you, and this is the point of contention, actually. We don't force you to make your record immutable. You can make it mutable if you want to. There's nothing inherently immutable about records. It's just that if you're making it mutable, you're probably doing something wrong because you now have things like your hash code depends on the values inside. And if they can change over time, that means your hash code changes over time, which means, and that's like a no-no. That's a design guideline no-no, because now you're putting your object into a hash table and it changes its hash code and you can never find it again. Things like that. So I would say that records are usually used for, we would assume that you would use records for immutable data. But if you want to have like a little cache or something in your record and handle that, or, we're not going to prevent you. It might be a thing that I can imagine that people would want to have analyzers that pick up on that. But we decided not to make it an error. So
I have a quick question. When I first got hands-on with records, I got a bit excited because I thought that maybe with the initializer properties, I thought that maybe you had to initialize them. So I thought it might help solve the problem of the nullable references, nullable reference types where you couldn't really use them with object initializers. Is there anything in the pipeline for that could help?
Yes, we're talking about in C#10 to have a feature that's essentially required properties. So you can say that a property has to be initialized.
Plus wanting that 100.
Right.
Thumbs up. I love that.
Excellent. Great. It turns out to be rather complicated. It sounds easy, and then you start looking at the details and you're like, oh, actually, you want different constructors on the same object to have different properties that they still require, and how does it work across inheritance? And so it gets into, it's been quite complicated. We're still working it out. We'll say the design that we're looking at right now is still a bit complex for my taste for something that should be simple. But hopefully when we noodle with it enough, we can come up with something that hits a good spot. Yeah. That's been a long-term problem, regardless of immutability and everything. It's sort of its own kind of problem since object initializers were added, and nullability exacerbated that a little bit. But the nullability exposed a problem that was already there. It's kind of how I like to think about it, because it starts giving you warnings about bad things. So we do want to solve it, but we're not quite there yet. Down with constructors, yes. There
is a question there from Miko.
Is there a default for records if you leave out init from a property? I mean, is it automatically init? No, there's no special magic currently around property declarations in records. However, that's a good segue to another thing I want to show about records, which is that if you do like constructors, if you do want to put constructors on records, you can, of course, just like you can declare anything else that you can declare in a class. You could go and declare a constructor here, like public person, yada, yada, yada. But you can also, there's a quicker way of doing that where you declare constructor parameters directly on the class. So you could say string first name and so on here. But you can only do that with parameter names that correspond to a member inside of the, that is a member inside of the record itself. And what I mean by that is that you either put a name that's already there, like I've done here, and now you can use these parameters to initialize them, or you can actually leave out that member and we will generate one for you.
Yes.
So that's why I'm saying that they will correspond to properties in the record, because if you don't declare those properties, it will make them. Which means that if you make a typo and you put first name here with a lowercase, like you usually do for parameters, then there's going to be a third property in there that's lowercase first name. So you have to be a little careful. There's some gotchas there, but it does mean that you can write very terse declarations. And the properties that will be automatically declared by the compiler will look like this. They will be public. They will be auto properties that have an init setter. So this is the default shape for properties generated by the compiler based on these primary constructor parameters, we call them. So I can write this record just like this, right? And it automatically gets a constructor. I can even leave out the empty body and just put a semicolon. And so this gets me a constructor. It gets me properties that get filled out by the constructor. It actually even gives me a deconstructor, so I can deconstruct back out from those properties. Positional deconstructor. Now, of course, I have red squigglies around my code because I'm not. Now we get into the whole like why constructors suck, which is now I have to put 3 parameters on student and pass 2 of them on, and you get sort of back into the constructor boilerplate game here. So you win some, you lose some. We're talking about allowing a weaker version of primary constructors on all classes and structs, where well, let's keep this one here, where they don't generate members, because that's not generally a thing you want to do from constructors. So we would do that only on records, but you could still take constructor parameters and use them in the initialization of the object by putting them directly on the class. So that's primary constructors. Serialization attributes can be added to this version of records. Yes. So if you put attributes on these guys and these parameters, they go on, by default, they go on the parameter itself, but you can also say, you can also target it with property, and then if I could spell property, and then they will go to the generated property, or you can target them, actually you can target them to field, and they will go to the underlying field of the auto property that gets generated. So you can decide where the attribute should go out of all the generated things.
There's a question just above that from McCall. Apologies if I've pronounced that incorrectly.
Oh, so you could have a completely empty record? Is that the one?
Is there a point in creating a write-only field in record type? Did you do that one?
Oh, creating write-only field. Not, is there ever? I think is the, I don't think there's ever a point in creating a write-only auto property. Because how do you, write-only properties are occasionally useful when you write them manually. And so I guess you could say that why should the getter be there? Why not just generate it? That would be a thing that's different from elsewhere. You know, sometimes we want to make things different from elsewhere when it's really useful. But it's a conceptual cost that I think you can put those 4 characters. I think we should stick with that. But yeah, maybe I'm wrong. Let's see, did I miss?
Connell's got one there. Oh, it's a big thing now. But yeah, Connell asks that property field, etc. syntax looks similar to the assembly syntax for attributes. Are they the same?
Oh, this is actually not new. This is something you can already do. I can't remember what's an attribute that we maybe just put attribute. I'm probably not allowed, but whatever. This is a syntax that already exists in C# that you can target an attribute explicitly. That's been there for a long time. Like I can put that on, if I put this on an auto property, in fact, it took a couple of versions before we implemented this properly. If I put that on an auto property, then the attribute gets applied to the underlying field rather than the attribute itself. So it's a way, also when you put it on a method, that's a way that you can distinguish between targeting the return value of the method versus the method itself. So target on attributes is an existing feature in C#. We just make sure that it works here where we generate many things from the same declaration. Bye, Stuart. Thanks. Let's see. Is that it for questions there? I want to show a few more things. Let's leave records behind for now and take a quick look at pattern matching as well. So I don't know how many of you have been playing with pattern matching. It sort of gradually crept into C# since C# 7. This is a fairly complex example of pattern matching that is C# 8 level pattern matching. We did a bunch of stuff there with switch expressions and so on. So let me just quickly give you context here. And this is an example that this is, if you go to our docs.microsoft.com C# document, this is the docs, this is the tutorial for pattern matching there. So you can go and play with this example yourself. But this is an expression bodied method that takes an object in, and we want to do different things depending on what type the object is and depending on its shape as well. And so we switch on it with a switch expression, so vehicle switch, and then we apply patterns, and we have results depending on what pattern matches here. So there are various things that are new in pattern matching in C# 9. A simple one is that if you're just matching the type, you don't actually have to say that you're not interested in giving the resulting value a name. You can just delete those discards here. More interesting, though, is that we have some new kinds of patterns. We see this kind of comparison to a constant value fairly often, and so we wanted to make a pattern out of that. So in these delivery truck cases here, instead of having a when clause in the pattern that applies a Boolean expression to the delivery truck to see if the pattern matches, we can turn that into a pattern match of its own. So we could take a delivery truck sight unseen, and then we do a nested switch on the gross weight class there, and then we apply patterns to that. And the thing you should notice here is that the greater than 5,000 doesn't get a red squiggly in Visual Studio because this is now a pattern in C# 9. Gets applied to this number here, and if it's greater than 5,000, the pattern matches, and the result of the expression becomes this expression here. And so we can go and fix up the rest, saving ourselves a lot of code along the way. Let's just close it out, put a comma there, and there we are. If the thing is a delivery truck, apply this pattern to its weight class, and then produce results based on that. Okay, so these we call relational patterns because they apply relational operators. Any questions on that so far?
Is that actually calling the operator, or is there some fancy?
It is, but in a sense it is. But you can only compare to constant values, and so the compiler knows exactly what's being compared to. That's one limitation that we kept in there because in general, even though we have pretty fancy patterns that can deconstruct and all kinds of things, we didn't want to make patterns that mean, we didn't want patterns to be able to mean different things depending on context too much. So, but yeah, the compiler knows that it's comparing to this. And we can actually see some of that, and some of the additional advantages of why doing this in a pattern is good in a second. I just want to introduce one more kind of pattern here, which is the logical pattern. Because now with more and more kinds of patterns available, and certainly the relational ones here, sometimes you want to apply more than one pattern. You want to combine patterns and say, I want to apply this pattern and that pattern, for instance. And so this last one here is really like the one that's in between 5,000 and 3,000. So we want to apply two relational patterns. And you can do that by saying greater than or equal to 3,000, and also less than or equal to 5,000. Right. So that's the explicit version of being in between those two here. And now we can move the patterns around so that they come in order, which looks nicer. So, and here is a logical pattern. Did I do something wrong? Let's see.
You need a comma somewhere.
Oh, comma here. Yeah, there we go. I knew I should have left that comma in.
I'll go betray some ignorance here. I just don't really get where I've seen this pattern matching stuff since C#7. I don't understand the point. I don't want to hijack this to a tutorial for me. So if you want to just tell me to be quiet and go away, that's fair enough as an answer.
No, it's great. But I think I think we've all had this feeling that if you have some complex Boolean logic, you're checking various things and you're combining if then else's based on the structure of incoming data and values and so on. It can get rather messy, and patterns do provide a way to more declaratively say what am I looking for and what do I get if I find it. That combines sort of both structure and types and so on. So it takes a little getting used to read it. But there's actually, I think there's a deeper philosophical reasons why we got into adding pattern matching to C#, which is, and at the time we did, which is that I think given the prevalence now of data that doesn't live in your program, but you sort of get it over the wire, you interact with it over the wire. Increasingly, object-oriented programming is sort of under pressure to dealing with that. If you have an object model of data in classic object-oriented programming, all the behavior gets wrapped in with the data. Like classes encapsulate data and behavior together, and then you can have virtual methods can sort of be used to describe when the different shapes of data have different versions of that behavior. They implement that behavior differently. Well, that sort of requires that you know all the behaviors that you're interested in when you write the data model, right? You put all those virtual methods in centrally someplace and say, these are the things that it can do that can be overwritten. But more and more you're working with data that's defined separately from the functionality. Many different apps will want to do different things with the same data. And so we need to be able to let you re-separate data and functionality sometimes, or many times. And once you have to do that, and for those functions not written together with the data to still have shape-dependent behavior, that all of a sudden becomes very clunky to write. And now you have to do all this is tests and is it this type, then cast it to that and put it into another variable and then dot into it and compare things. And that's where you get that very complicated imperative logic that is very error prone and hard to read, easy to mess up when you refactor. And pattern matching is sort of really again, it's lifted from functional programming and how they do things in many ways, but adapted to an object-oriented context. But pattern matching is really there to provide the answer to how do I write elegant shape-dependent behavior outside of the class hierarchy itself. Does that make sense?
Thank you.
I mean, so if you need to do that, then you should look at patterns. It's essentially, they have a bit of a learning curve, but and especially because we're pushing new things into them every release right now as they're kind of growing up as a feature. But they really help you in those scenarios. All right. And so let me see. Did any questions come in? Did any of you organizers notice new questions in the chat?
Don't think so. Just comments mainly. I mean, again, if you've got a question, then unmute yourself by all means. If you don't feel comfortable with that, and we've missed your question, then just prompt us in the chat, and we'll find you.
There's only the one from Connell that said, why not double ampersand rather than and?
And just in general, it sort of follows on from our is it calling the operator? Like this to me feels very different from your if statement conditionals. Like, can I use any comparison operator? Have you got a keyword for an or there? Like, or is this just totally different syntax that I've got to forget about my if statements and think differently?
Right. So we certainly thought about several good questions in there. And,
I got another one after that. Sorry.
Cure it up for a second. So first of all, we have more than and. We also have or. We have not. So and or not are now pattern combinators, if you will. I could, like down here, for instance, I could say not null. Null is a constant pattern. Not, well, if I could, again, if I actually knew how to code. Not null is the opposite pattern. It's the one that matches when the thing is not null. And so that's very useful to be able to say. You can say that before. And there's an or pattern as well. Now, why didn't we just use the already established syntax for and, or, and not in C#? Why didn't we let you put this? And the reason is that it is wildly ambiguous from both a compiler standpoint to figure out, because there are expressions inside of the patterns, and patterns sometimes are part of expressions when they're in themselves in is expressions. And so the intermingling of patterns and expressions means that what the double ampersand applies to is, whether it applies to patterns or to expressions, is very hard, not just for the compiler to sort out. We could probably figure it out, make some rules and figure it out, but also just for the reader to distinguish the human eye. Like this here maybe makes sense, but it gets a little more complicated and it starts to really hard to just suss out what this whole thing's about. So we said, okay, we need different, either we need to not do this at all, or we need different words for it. And we've been chewing on it for a release or so before we said, okay, you know what, the words are fine. There comes a time in every language where you have to say and with words, apparently.
You mentioned there expressions. So already in the language, there's a difference between your sort of computational function and an expression tree. And the comparison operators are used in both of those, right? And could potentially mean different things, unless I'm misunderstanding that. So have you gone, we don't want to introduce a third one, or is there a different thing between, A, B, and C in that case? So for example, like linked to entities, my the expression tree as you're looking at that at runtime.
Right. So pattern matching isn't currently interacting with expression trees. And there's no way, I mean, the expanded is expression is not representable in an expression tree. So there's currently no interaction between them. You could imagine a day where an expression tree could represent a pattern match, and then it would be up to whoever interprets the expression tree to implement the pattern match. And part of the reason why we haven't expanded what expression trees can represent is that then puts an onus on everyone who is currently consuming expression trees to start understanding new things that show up in them. So we haven't gone down that path. It's sort of riddled with danger, and we've left it for several releases. So to some dismay among people who want to use them for more things. But in this case, it means I have an easy answer to your question. They don't meet.
They just I get a compiler I get a red squiggly if I try to use that in
exactly.
Queryable expression. I guess similar. My other question was on: is there any short circuiting in these ands and ors operators? If it's not really imperative, does that even make sense as a question to ask?
It does in terms of the work that the compiler does to figure out whether a pattern matches or not. And the answer is that the compiler, because all the patterns are constant, the compiler actually reserves the right to and does quite a lot of reshuffling of the logic that happens in a pattern match. It will feel free to reorder things, to put things that are part of multiple patterns, like for instance, the 3 bus patterns here. It reserves the right to only check for bus once and then go, it'll do all kinds of things to optimize the execution of the whole, because it's so declarative. It can reorder execution. Sometimes that does lead to a change in the order that certain properties on member or on objects are evaluated compared to what the order they show up in the source code. And that's part of the specification of pattern matching, is we allow ourselves to do that. You should not do side effects in property reads. I'm sorry. If you do that, you might be able to observe this.
Fair enough. Thank you.
Mads, it's 9:05.
Yep.
I'm not sure what everybody else's feelings are. We've still got 55 people watching, so my feeling is that people are still very interested in what you're saying. So the last thing I want to do is cut you off in your prime. So here, but I don't know what your plans are, how much content you were wanting to get through, how long we could keep you, or what.
We're so I'm at the end of things I can show in Visual Studio pretty much. I was going to show you one arrow squiggly in the patterns, just and other than that, we can chat, we can talk some. I've already touched a bunch actually on things we might want to do in C#10. So most of those slides are a bit moot by now. Mm-hmm. So I think that we're a good place to wrap it up.
Yeah, I mean,
sorry, Pete. There are a number of questions in the chat still as well.
Yeah.
I mean, what we could do is quickly announce the competition winners and then carry on as long as you want. To be honest, people seem to still be eager and watching.
Yeah. Why don't we do that, and then we keep playing around in this code and take the questions as long as they come, and when that peters out, we call it a day or a night in your case.
Perfect. That sounds perfect to me.
Pete, in that case, do you want to announce the winners?
Yeah, so it's been quite different. There's not been that many people who wanted to win the bit, it seems. So I think, what have we got? 1, 2, 3, 4, 5. We've got 5, as far as I'm aware, we've got 5 bit packages to give away, and we've got 5 people here to choose from.
Oh, no, those are the people who I selected from the whole thing.
Oh, were they? Oh, sorry, yeah. I misread Jess's Slack message.
These are the winners.
These are the ones that have been chosen by our random method then.
Yes.
Oh yeah, in fact, there's a message underneath it. That's exactly what she said. That's what you get for not reading what people are typing to you. Either way, the first winner of the bit package is Connell Watkins.
Woo!
I specifically did like your selfie as well. That was pretty good. I don't know if I retweeted it as well, actually. So you'll see that on the .NET Knots channel there. That was really good.
There we go. Like and subscribe.
The next winner. These are Twitter handles I'm reading out here. Is Mr. Benbot, Ben Lee. So I think so long as you've done these tweeting, I don't think you necessarily have to still be here, because now we've gone on quite a while. I think it's unfair for people to have to be here, but if you are, then that's good. The next one is Carl Sargonar. So apologies for not being able to pronounce your last name, C. Sargonar, on Twitter. The next winner is Alan Buxey. Alan, you're quite lucky at this. You do seem to win every now and again. I know you're here. Congratulations.
Something different. I'm looking forward to that.
Yes, absolutely. The final winner of the bit package is Andy Douglas 1967, Andrew Douglas. So congratulations. I see your name in the list there as well. So thank you so much to Microsoft, specifically to Adam Jackson and Claire Smith for putting that pack together. This isn't something we do every month. We I went cap in hand to Adam and Claire and begged them for some swag to give away, and they very kindly donated some things there. So what we'll ask you to do is if you could follow us on Twitter, and obviously these are physical things, so we'll need your address to be able to send them to. I'm not sure yet whether or not it will be direct from Microsoft or if Microsoft will send them to me and I will send them on. And I'm also not 100% sure on timings, because obviously places like offices are closing and not open to people. So it depends on when Adam can go in and get all of these bits together and then either send them or send them to me. So there will be a delay, but we will try and get them to you before Christmas so you can have something cuddly on Christmas Day. And then the final prize is the JetBrains license. And hold on, I need to open the image. And the winner of that is @Has_Ack. I'm not entirely sure who that is, actually.
Ali, who's still online.
Oh, Ali. Oh, yeah, it says Ali at the start. Yeah, I missed that. So again, follow us on Twitter, send us a DM, and we will get you the code. Sometimes when we send you the code, you'll need to use it almost immediately because of how they expire. So keep that in mind as well. But congratulations to all of them. Thank you very much to our sponsors of obviously JetBrains for that JetBrains license, and then Microsoft and the MS Dev UK community there for donating the bits. And obviously at this point, it would be wise as also to thank Mads for his awesome talk and for taking time out of his day to come and speak to us. It's fantastic, really good, and round of applause for Mads and his talk there. Obviously, needless to say, the other sponsors that we have, Stickers and my company PJG Creations, but they take a backseat to the people that I've just mentioned to a degree. So thank you very much indeed for that. And with that, I mean, obviously we can take a couple of minutes if you need to go and charge your glass and have a bio break. I liked that term there, man. That was good, a bio break. I'll use that from now on. Stolen. And then we'll come back and we'll just carry on until I don't know, Mads' superior comes in and tells him to get off the phone.
That's a good thing about home offices. Yeah, the command chain is shorter here.
True. Partner or pet, usually. If you got neither of those, then we're all sorted. So. Yeah,
got really plenty of questions to scroll through as well, which is great. People have still been posting while we've been chatting. So
excellent.
All right, thank you for the talk, Matt. I'm going to head off and get.
Don't see you, Liam. Merry Christmas.
Yeah.
Good to see you again, Liam. Yeah. Merry Christmas.
See you. Bye.
See you later. Bye.
That's one other thing I want to thank is all of you lot online who have been posting questions and saying questions and making this a discussion, because normally with meetups this is really hard, but this meetup's really good for interaction, so thank you all.
You are 100% correct there, and my bad for not thanking the people that make this meetup what it is.
What's to do with me?
Yeah. I mean, I could live with just sitting and listening to Mads talking about that, but yeah, the community section of this is specifically important to me and Jess. So thank you all for coming along. It's been good, and yeah, great questions.
Yeah, it's been great. I mean, this has been an unusual amount of question. That's been great, and that's what that's why I show up, is for the interaction. So I had a great time, and these questions make me think, and they make us go and consider what to do next as well. So it's just part of that feedback loop that we get.
That's awesome. I mean, I'm guessing that we can raise GitHub issues against this because it's all open source and developed in public now. So, you know, if we have feature suggestions that we'd like to solidify, we can go and raise a GitHub issue and put that sort of request in.
Yeah. Now that GitHub has discussions, typically ideas start out as discussions, and then if it feels like it has legs, then it can become like a fully fledged proposal. And either you should feel free to, that sort of takes the burden off bringing an idea for initial discussion. You don't have to have it all thought out, just raise it as a discussion. And if either you or someone else feels like I can really go and express fully what this should mean in C#, then put it as an issue, as a proposal, and we'll look at it.
There's heaps of questions, but I had one first that was sort of a tangent, really. I've been involved in creating quite a few Microsoft certifications. As far as I'm aware, Microsoft have got rid of language certs now. Is that something that your team gets involved with, or has there been a discussion around there used to be the MCTS, whatever. I've got a book up here on the 7536, it used to be called, and that was a VB one in specific, that was. But I think they're all Azure and DevOps and stuff like that now.
Yeah, I have no insight into that. We haven't been involved in that. I don't know why. I guess I can imagine it's some sort of mix between what people express to Microsoft that they would like and what Microsoft wants people to want to do. So that's probably
it seems like it could be something quite useful, certainly with how the language is evolving, and maybe that's part of the problem, in that it's evolving faster than they can afford to keep the exams up to date. But we know we can certify people for IoT, we can certify people for DevOps and for Azure architecture, which are all really important skills. But having a certification for somebody to have walking into a job would give you a little step up, you'd imagine, in that obviously you know how to program, or you have a certain level of knowing how to program, rather than relying perhaps on the really bad fallacy of requiring things like a university degree to get people into their first job, which is a horrible requirement that some companies stipulate.
Right. I think all formal expressions of skill have both pros and cons, right? They're more easily verifiable and interchangeable, but on the other hand, they maybe take focus away from what's important about the person. So I can see it either way. But I have no specific insight into. I didn't even know the language certs weren't there anymore, actually. So I have no idea.
I'm wrong, because Alan, no, is it Alan? No, Ali, no, somebody in there. Richard Parry, apologies, said there's 74X3. I was sure I heard a discussion about the not being language certs, but there's a cert there for programming in C#. But I mean, the question is still interesting. I didn't know whether or not your team got involved with having to work out what goes into those exams and what's tested, being as you're creating the language.
I don't think so. I haven't been asked to weigh in on that, for sure.
Okay. Apologies for usurping other people's more valid questions than that. Did you want to scroll through them, or did you want us to find the question?
Let me show one more thing in this switch expression here, one or two things, and then if you can help me scroll through the questions, that'd be very useful. So I just wanted to mention there were good questions about why are patterns good, and one other thing that's good about patterns is that they can check more things about your code, and I think I wanted to stress that. So let's say that we make a mistake in this pattern. Okay, so let's say that maybe I put 4,000 here instead of 3,000. Now I get a warning on the switch saying that it's not exhaustive. So because I expressed my logic as patterns, the compiler can check that the patterns actually exhaust all the possibilities of the incoming value. And here it's saying that, for instance, it even gives you an example. If you put the value of 3,000 in, this pattern does not handle it, because I forgot between 3,000 and 4,000, right? So it gives you that kind of feedback that is that's helpful, especially as your code evolves and so on. It's helpful to keep it correct.
That's cool.
So I could also, let's say I forgot this part here, I can get an error saying that you'll never get to this last pattern. This pattern is unreachable because every possible value coming in would have already been handled. So this is part of what pattern matching really does. It's part of why people like it in functional programming, and we can't do all the things they can do in functional programming. We can do a significant amount of checking for you, and we do.
That's interesting that it generates an error when you do that, because the code is still valid. It's a bit like having unreachable code after a break or something.
I think there was a warning instead of an error.
It was quite quickly.
The exhaustiveness is a warning because the pattern, if a pattern match is or if a switch is non-exhaustive, it will actually, and you reach the end, it will throw an exception. So we do handle that in a sense, just a bad sense. So we give you a warning about it. But the unreachability, we chose to make that an error. You can always, The thing is, you might want the other thing, whereas this is clearly not useful. Like having case you can't reach is not useful, so we give you an error about it. But
yeah, it's just weird that that's not then followed through in the rest of the C# construct. Like I've just
yeah,
said,
yeah. Maybe if we went back, we might want to choose to make all the unreachable code an error, but that would be
it's
a
a pain
breaking
for
change now.
debugging, though, isn't it? Because sometimes we sort of just stick a statement in to stop or something before while we're debugging, and now you can't debug.
That's true.
It's a bit more terse, isn't it? That. Did you want the questions? Did you want some of the questions?
Yeah, let's do the questions. Yeah.
Cool. So Marcelo Videra, apologies, I'm terrible at pronouncing names. This was back at 902, so I don't know if this has been answered, but can we use more than one property on the same expression? For example, GRU, weight, class, and XYZ? It's right back at 902.
Can we use more than one property on the same expression? Yes. So that's where you would do something like a recursive pattern. There are two kinds of recursive patterns, and they're both in C#8 already, but that's only a year ago, so still fairly new. Which is the property pattern, as we call it, where you inside of curly's here you can mention one or more properties of fields, colon, and then apply a pattern to them. And here I'm only applying constant patterns, but I could do, let's say that there were other, I wonder if there are other fields in taxi. But if there was another field, you could also, a property, you could also use that here, other property, and you can apply patterns to them like that give those values names. I could call that var o, and that's a pattern that makes that other, takes that value of that other property and puts it into the variable o, so it can be used in the expression over here. And so you can indeed have patterns that collect multiple values from various places in the value, in the tree of values, even recursively, and then uses those values in the expression or in a when clause on the so it can get fairly complicated, but the answer to the question then is yes. Here you actually see me take two different, this is a positional deconstruction where the bus type in use here apparently has a deconstructor on it declared, so I can deconstruct it positionally, and it gives me two values out, and I'm choosing to give them names and use them later here in the when clause. So that's a way to hoist multiple things out and do things with them later.
Is that the out type or something you're using there? I don't know enough about how that's working.
Yeah, deconstructor has is a method called deconstruct that has out parameters for each of the things that you want to have come out. Yeah.
Cool. That's one of the things that's not in VB, I think, isn't it? Out parameters or something. I'm from a VB background. You may have noticed that. By the way,
I suppose you can do a lot with tuples now as well. Like your try pass that has an out param, you can just have a tuple that is a bool and the thing that you want out.
You could do that.
Multiple types. What's the point of out params?
Well, actually, the try pattern is an example where out params tend to be better, because then you can put the call of a try method directly in an if, because it only returns the bool. And then you can hoist out the result. If it turns out to be true, you can hoist that out in an out parameter. And now you can say out var x directly. So you can declare the variable where you get it out. And then that variable x is
scoped to your if block. Yeah,
it can be used in your if block. So actually, that's better than tuples. From the perspective of the structure of the code where you consume it, becomes nicer.
Awesome. Then back at 9:10, Dado asked, as much as they're extremely useful, pattern matching, I think they have got a negative readability, maintainability side effects. Are the best practices to keep the complexity under control?
I think, yeah, it's a bit of especially with recursive patterns and so on, it's a bit of a big gun. Things can get just, here and many other places in C#, you have expressiveness that you can sort of go crazy with. The same is the case for link expressions. All the way back when we introduced query expressions, someone on my team published a sample that was a full ray tracing application written as one single link query. That was like a couple of pages long, and so you can definitely take things to extremes. I would say use the tools that make the most sense for the situation. A little bit of a problem with switches and switch expressions here is that they're terse and they're nice, but sometimes they run out of steam, right? They can only have expressions as the result. So what if I wanted to, do statements? Then I have to go back to old-fashioned switches, and everything becomes more elaborate, if you will. But so there are these problems where then you feel tempted to do convoluted things, and you just use, I don't know that there's specific guidelines here other than use common sense. If you're like 3 levels deep in a recursive pattern, maybe, you're doing something wrong. Unless it's just beautifully clear, like the whole structure just glares out at you on the screen. This 3-layer deep thing is like exactly maps the way that you think about the objects. Maybe that is just the right thing. Yeah. Always dangerous, putting powerful tools in the hands of people.
With great power.
Yeah.
I think I've skipped all the way down then to 22 minutes past 9. Steve Terrapin has asked, code contracts were nice. Did they go away? What's your thoughts?
Code contracts. We talked so many times about should we add support directly in C# for contracts. Code contracts was this thing on the side with attributes and stuff. You could annotate that certain things would be true or should be true on input or output, a relationship between input and output of a given method. And so essentially designed by contract. And we looked a bit into whether some of that should be supported directly in C#. But what we found was that the 90% use case of code contracts was checking nullability. And so we made a feature for that instead. So nullable reference types are really the thing where we said, okay, if we do this just for null, then on the one hand, it's a lot simpler. It covers the 90% use case. And also we can make it much better than if the null thing was traced through a generalized sort of like Boolean annotation system. And indeed, then the nullable feature is much more expressive than what contracts could do. So we chose to focus our efforts there. If there is a residue of, a residual demand for expressing more complex contracts, I think we will start noticing that over time as the nullability stuff gets adopted and sinks in, but we're not quite there yet and might never be. There might just not be enough use case left.
And then, you can come off mute, Steve, and ask the question directly.
Okay, I'll ask it then. You were talking about try the out pattern just now. Are there any plans either in C# or the Blaze class library to bring sort of the maybe monad, like sort of functional programming, which I kind of guess what the other person was alluding to with tuples?
Or monads in general, I suppose. You got to select many. You can try and abuse link to do it.
And that was my thinking of being able to compose link statements without having to jump out with if statements.
Right. So, probably not everyone knows what a monad is, because it's not something we ever fully embraced in C#.
I don't think anybody knows what a monad is.
Yeah, I'm not sure either.
Yeah, even including people that use them daily, they still don't quite know what they are. But essentially, they're the sort of mathematical category theoretical underpinnings of, for instance, the query expression feature in C#. And essentially, it's sort of loosely this idea that you enter into a, I don't know how to best put it. monad is a certain structure that lets you compose code sort of conditionally that gets applied on the underlying representation according to certain rules. And there are different monads that you can build. One is the query monad, or the that LINQ uses. Another one is the async monad, which is how a language like F# does async, which composes things on top of each other based on when they come back from something asynchronous. And a third option is the maybe monad, where you write a sequence of statements that will only come to pass if the previous thing ended up not being null. So we chose, if the question is about monads in general, we've chosen not to support those in C#. Okay. For the maybe monads in particular, there's a discussion there that's related to having option types, which is essentially a type that represents that a value is either there or not. A value of a given type is either there or not. And maybe monads are sort of like, you would layer those on top of option types. And option types are another form of nullability in a sense. They're not quite the same, but they're close enough that we've resisted the temptation to embrace them in C#. Because now we have two kinds of null, and we have to explain when should you use one versus the other, and how do you combine them. And so we just said, nope, C# has, for better or worse, C# has its notion of null. And we're just going to stick with that from a language standpoint.
And I guess you've got null coalescing as well, so you can kind of work around it.
Yeah, we built that kind of feature around the null concept. And the sort of static tracking of it now in terms of the nullable reference types, the various null-based expression forms and so on. So we're like, okay, we think we're good. There's certainly things you could do more elegantly, but then at the high conceptual cost of having two kinds of null in the language, which we all know from JavaScript, you know, what life is like when you have two nulls.
What? Thanks.
And with the option type, you would actually have many, many nulls. You would have one for each type, right? Because of every option of t, for every t, it would have its own null. So it would be even worse.
I seem to recall that Eric Lippert had a decent series on monads in C# a few years ago on his blog. Might be worth reading if you're interested in that sort of thing.
Yeah, and he also talks a lot about nullability. So, yeah.
Do you mind sharing a link, Mark, and then we can attach it to our blog later on?
I'll just dig that out.
I feel like every time I try and look into what a monad is, somebody mentions the nullable type, generic type. Somebody goes, yeah, here's a nice example.
Yeah. Yeah, you get option of t, and then it's either, or maybe of t, they call it different things. And then you can describe it as an inheritance hierarchy or as a discriminated union, where the top type is maybe of t, and then the two different specific possibilities are, yes, I have a value and here it is, or no, I don't have a value.
I had another quick question on this pattern stuff. So I was doing a quick bit of playing, and I noticed you could put things like the less than 3,000 on the right-hand side of an is. And I was wondering how far that extends. Could you do, because I haven't got a compiler here just to test it, but could you do things like taxi fares 0 on the right-hand side of an is in an if statement, for example?
Is 0?
No, so you could say if X is taxi brace fares : 0.
Oh, yeah.
Or does it not? Does it go that far?
This pattern here, this is a pattern, and patterns can be applied in an is expression. So absolutely, yes.
Nice.
And then you could put
even the when statements as well.
Not the when. The when. Okay. So the when is not part of the pattern. It is part of the switch clause.
Oh yes. Okay, I see.
Because when is sort of like when this pattern applies and this Boolean extra condition also applies. And if you're in an is expression, you can just say double ampersand at that point and apply extra Boolean thing. Since all the variables that you introduce in the pattern, they're still in scope for the rest of the expression. And so you can use them in subsequent Boolean conditions.
Yeah, I had a rumor that there was somewhere on the roadmap the temporary casting on an is. So if you did if X is taxi, then X would become taxi within the remaining scope. Is that something that's still on the roadmap?
We no, and we ended
I
up.
can see why that might be not a good thing as well.
It's a breaking change. If you have, because you can already say that today, and if you don't strengthen the type, there might be members visible that would otherwise be hidden by members that you discover when you strengthen that type. So that will be a breaking change. However, you can say if X is taxi T.
Yeah.
Taxi T is a pattern, and now T is available as, and that is X, but as a taxi. And in the true branch, it would then be definitely assigned, and you can use it as a taxi. In the false branch, then T would still be in scope, but it would not be definitely assigned because the pattern failed, and so you wouldn't be able to observe a T when there was no taxi. So we do all that through definite assignment, making sure that you only get at those variables when they are indeed meaningful.
Yeah, but so in that case, you could do something like if X is taxi T and something.
Yeah, double ampersand.
The else clause would still have the taxi if it was a taxi. So you could have another part of that.
Yeah, you could do that. Well, the else clause would not have the taxi then, because we don't know if it failed because there was no taxi or because the other condition didn't work out.
Oh, no, I see what you're saying.
Cool. Anything else?
I'm sure there were.
There's a question for Pete, actually.
Oh, geez, really? Where's that?
At the very bottom.
Oh, is the deadline to message you to enter the draw the 17 days as on the challenge? I believe so. Yeah, there is an end date. So yeah, that will be it. So yeah, you must make sure that you've done at least 5 of those modules, as far as I'm aware, before that date. Otherwise, you will not be managed to enter, I don't think. Obviously, what we're expecting is that more than the limit of people will actually complete the challenges, and at that point, we will just use a randomizer to pick the number of people out. But there are a fair number of prizes, but obviously there's only one Surface Go, I think, and only one set of Surface headphones, but there are 10 exam vouchers, and I think, did Adam say 10 bit boxes as well? I can't remember now. But it's well worth having a go. And again, apologies, it's only UK people again, because there's physical items to ship. So, and yes, MVPs can enter. I can't, and Jess can't, because we're organisers. So as of tonight, I quit. And
you got in there before me.
Suddenly, there's no organisers of .NET Knots left, but there are lots of people competing for.
You can just be furloughed for a day these days.
Yeah. To be fair, we have no more meetups till the end of January now, so we can be furloughed for 2 months there. So, so that's that one.
I think it's the next one, the null check bang bang feature.
Go ahead.
Question.
Oh yeah, will the null check bang bang feature be in C# 10? Yeah, so
right. So the answer is probably yes. One of the, this is sort of like a follow-up to nullable reference types. But if you look at exceptions, well, one thing is exceptions thrown. The system throws a lot of exceptions on its own, most notably null reference exception. But if you look at exceptions that are explicitly thrown in code with the throw statement, then null argument exception is argument null exception is probably, by far the number one, because somebody does argument checking, and the most common thing to check for is this thing null, in that case bailout. And even with nullable reference types, if your thing is public, you can't be sure that people, even that you say you only take nullable parameters, you can't be sure that people abide by it. And so you still want to check, but it's annoying to have a line in your method for each check there. So what we want to enable is that you can say bang bang on a parameter, And what that means is this has to be null, or this has to be non-null. And the compiler is going to generate the check at the beginning of the method, and it's going to throw the exception in the obvious way, throw a new null, argument null exception with the name of the parameter in there and everything. And that's just going to be a way to do that much, much shorter. So
what's the difference between bang and bang bang? Because I thought bang was a non-null check.
No, bang is a thing to say ignore any null warnings here. So that's sort of the do what I say. I know what I'm doing.
Gonski calls that the damn it operator.
So, yeah, the damn it operator. And the bang operator doesn't do anything. It just silences compiler warnings. So it doesn't have any effect on the running code. It's just part of the system to manage the warnings you get in nullability. This here, though, has real runtime effect. It will check and throw. So it's really a shorthand for generating that check.
So will the bang bang operator make sense to run on its own with no assignment? Just the first line of my method can be variable bang bang or parameter bang bang bang.
Yes, it will make sense. That's not part of the feature we're thinking of in C# 10, but you could certainly imagine it being available in other places as a statement, as an annotation on properties that would apply to the setter. You name it. This is by far the most common one. So we're going to do that one first. And if people like it, we'll probably keep pushing bang bang into more and more places until you've had your fill. But yeah, it has, and that's part of why it's new syntax, right? There's no other place in C# where you can say bang bang. It's so that we can push this to any place where we feel it's worth it later.
That's really cool.
We were initially talking about just having a bang here, but then that would get confused with the other bang that's already in the language. Well, several bangs that are in the language.
It's a talk from Bill Wagner that was suggesting assigning to a discard just to sort of get around this. And it was like your first line of your method just to do a null check would be like a underscore equals your variable name, question mark, throw new null reference exception. And it was just it felt a bit abusive. It was like, it doesn't seem like it was meant to do that.
Right.
But yeah, bang bang sounds like it's meant to do that.
It's the opposite of a question mark, isn't it? I think, is that how that's working? So the question mark is like just assigning it as to be nullable. Like you can have a string question mark or whatever, and that means it's nullable. Or didn't question mark would probably be a better example. And bang bang means you definitely can't be nullable. Right. I don't use that particular feature, the bang bang feature, so I've not seen that used before.
Right. No, but that's because it's not there yet.
Oh, geez. Okay. Well,
this would be a C# 10 feature. So that's part of the question. And important to note is that the question mark for nullable reference types goes on the types. All right. I didn't turn it on here, but it goes on the types. The bang bang feature goes on the parameter or on the thing to be checked. So.
Right. Is C# 10 .NET 6 or .NET 7 or what?
.NET 6.
.NET 6.
Yeah. I mean, we haven't sort of like officially committed the same way that .NET has to having a new major version every year, but we're definitely going to try that for a while. And if it works, we're going to keep doing it with the C# language itself to have a major release every year.
Right.
And then you'll see more and more of this where, just like I was talking about with this feature, where we trickle out a feature little by little over several versions as we do the most important scenario first and try to think ahead and not block future scenarios with it, and then gradually take us to where it needs to be long term. That's worked very well for us with the pattern matching as well over several releases, where started out with the most key scenarios and then added things that seemed to be the most useful next thing that people were asking for.
Right.
So that's kind of a new mode. Instead of a big theme and here are all the fully finished features, C# is a living language and it will gradually evolve. Features will, medium to large features will trickle out over multiple releases when that makes sense.
And these are all still decoupled from Visual Studio specifically as well. So we can have different releases of Visual Studio to .NET, but you'll likely get a new version of Visual Studio when there's a new version of .NET.
No, well, you get new versions of Visual Studio all the time now. So it just, the new .NET just at any given time, or the new C# supported in whatever VS release comes out at or shortly after that time.
And they used to be quite tightly coupled, I think, didn't they?
Yeah.
VS releases and .NET releases. So
yeah, we don't have to do that anymore.
Same for Entity Framework as well, I think. Is that decoupled from everything now? It's sort of a NuGet package almost, or is that tightly coupled somewhere that I'm not thinking?
I think Entity Framework follows along with I don't know if I can't remember if they're bundled in with the .NET Core releases now, but it certainly follows the same schedule, I believe.
Right.
But,
I mean, that must be quite a big job to schedule all of those separate pieces of work to sort of follow along, if that is the plan, at least, to do that. I guess you get pulled into meetings about scheduling at some point in the year.
Oh, yeah. And there's a lot of prioritization work that happens on a running basis where I guess we're not shipping this feature in this release after all because it doesn't fit the schedule.
Yeah.
But it's actually easier when you have a date to schedule to. And when there's going to be a next version, you don't have to try to cram everything in because, it's a last chance in the next 2.5 years, or who knows when the next release will be, or anything like that, like it used to be. We just have trains that leave the station every year. And if you're not on that one, you're on the next one. And it's much easier it's less of a management nightmare than the other thing was. It's much easier now.
That sounds good. There is another question from Kevin Smith. I don't know if you answered that. Is there any language feature in the future that will be like the let in Kotlin? Pretty right near the bottom.
Let's see. So you can tell it to only run a block of code if the value is not null. Not exactly like that. I mean,
He doesn't like it.
Well, you sort of have it for expressions, right? You have the null conditional operators to some degree, or you can just check for null. But there's no like shorthand for having a block of code that only runs if something. I don't have that particular thing. I don't think top of mind.
It's just quite terse, I found when I was writing Kotlin.
Yeah, you would have to do in C#. You would have to do something like is not null, if blah blah is not null. Then you want it as you want a variable name for it. And actually, okay, so there's a little bit in C#9 where you can say, we specially support you being able to say if some expression is not null X. So if it's not null, give it the name X, and then you can use that in the body of the if, so that it lets you do a similar thing here where you name the thing. Here they use a special name, I think, which is it in Kotlin, and here we let you explicitly name the thing that is not null and use that.
Yeah,
say it's coming if
as well, yeah. But yeah,
because it might not already be in a variable. If it's a variable in a variable and we check it, then the null tracking machinery knows in the body of the if that it's non-null in the body. But if you don't have it in a variable, you can sort of check it and get it into a variable at the same time, and now you have a name for it in the body. So yeah, we let you do that in C#9. Yes, if person is not null, it. Yeah, not quite as terse, but getting
I
there.
think there's a question from Dave up at 9:37. I'm not sure if you answered that. With a constant return requirement, what happens if the base fare is changed in the example? Would the whole pattern have to be rewritten?
With the constant return, what happens if the base fare is changed in the example?
Dave's still here. If you wanted to come off mute,
Yeah. So you mean if the so how do you update your code? How do you change the patterns programmatically to respond to changes in pricing structure or something like that? that the question?
I'm scrolling back down to the bottom of the see if he's replied.
He said exactly.
Oh yeah.
Yeah.
No mic.
Yeah, that's a problem. You pretty much can't. You would have to like put the key numbers in as named constants, then in a central place, and then you have to change the constants and recompile. That's like that's a limitation right now, and it's, as I said before, we've stuck to our guns so far on the patterns themselves only having sort of like constant expressions in them. We may choose to look into changing that at some point. We've kept our syntactic options open to do that. But we just haven't done it because of the implementation consequences of that, and the ways that it will limit the amount of optimization we can do and so on. But it might be in the future that we could indeed have the patterns themselves respond to non-constant values.
I think you got that. Dave said, I understand. Thanks very much. He doesn't have a mic. So.
All right, okay. Let's see.
Do you have an open page with upcoming features like that bang bang operator, for instance? Is your planning in public as well, or?
Yes. So here's the C#Lang GitHub site, which is all about language planning and design, and all our planning is in here. We don't have another place where we do planning. The design planning is in here, and the implementation planning is in the sister repository called Roslyn.NET Roslyn, which is where the compiler lives. And there are a couple of places to go look. If we look at issues and pick the milestone called working set, that is the very large set of features that we are currently working on from a design perspective. That does not mean that they're all scheduled for the next release at all. That just means these are the ones that we're actively considering. We used to try to bucket them into what release we thought they would go out in, but that now that we're on yearly releases, that changes all the time, and that's too much bookkeeping and doesn't really give much value, just a bunch of false promises or expectations set wrong. If you want to see what's being worked on actively, on the compiler side, I think I just ran out of battery in my, this has been a long session. Let's do this. Sorry, you'll be coming out of my speakers now, so it might be a bit of echo.
Oh, that's okay.
So on the compiler side, let's see if I have a shortcut for that. Language feature status. Here over in the Roslyn repository, you can see where this currently active work, and this is sort of the planning page for features being built in the compiler right now. So here's a parameter null checking we were talking about before, for instance. And this is going to gradually fill up as more and more C#10 features get started on from an implementation perspective. So you can track all that. I'm going to paste this one. This one is a useful one. I'm going to paste that in the chat.
Ah, good. That saves me trying to type that in.
Yeah.
I can get to the Roslyn thing, but I wouldn't know how to get to that now.
Right. I think it's linked on the front page of Roslyn as well.
Oh, is it? Okay.
Actually, let me take this. Let's see, did that one go out?
I mean, that's really cool to be able to see the planning process in public for something as big as that, and to see what's coming. And yeah, it's really interesting. Do you even get like nightly releases somewhere where that's been worked on and you can actually play with real cutting edge stuff like
that? We haven't done nightlies per se. You may be able to, you can fish out from the, I mean, we have, generally the feature work is going on in different branches and relatively rarely being merged back into main. but you can certainly go and grab the compiler from those branches. Are you familiar with Sharp Lab?
No.
Let's see. This is a website where you can go and paste in code and see what it turns into. And you can pick different branches here. So they update it with branches for, with compilers taken from different branches. So this is not something we build. It's a community effort. So if you want to see the attributes and local functions work, bunch of different branches here. You can go and try that particular branch, put some code in, and see what it results in terms of compiled code, or you can run it and see what comes out. So it's a really good. We use it a bunch to just like play with little examples, and so that's a way to. Play with the unfinished code. Also, when we have experimental features, when we merge them into main, they tend to become available under the preview language version. So even in shipped versions of Visual Studio, if you set the lang or the command line interface, if you set the lang version to preview, then there are typically some features in there that we're currently working on that are available even in the production compiler under the preview flag. You can actually, without downloading anything special, running anything special, the actual production compiler has these features in it. It's a very good way to get a feature out to a lot of people to use. And to our own amazement, this has not been a source of much instability in the main shipping code of the compiler. It's actually, we've been really good at keeping the discipline and keeping the instability related with these unshipped features isolated to when you use them, and not to when you use the compiler for production code. So that's turned out to be a surprisingly good way of sharing sharing access to early versions of the features.
I like it. Does anybody else have any more questions? Oh, Connell's asked, have you decided on shapes and extensions yet? What's that about?
The shape.
Talking about the C# Lang GitHub. That was one of my favorites from a few years ago.
Right. So there's a couple of somewhat dated proposals out there that I actually wrote up that we are now starting to look at in earnest. We actually have compiler resources now to start investigating these things. There are a couple of features that I won't say much about them since we're 3 hours in, but the part of the idea is, if you think about the kinds of coupling that you have in code today, if you have a class and an interface and you want the class to implement that interface, then the interface better be available and known to the person writing the class so they can implement that interface at that point, right? But if you're someone trying to bridge between existing classes in one library and existing interfaces in some framework, then you can't do that. You can't adapt things to each other. You can't apply an interface after the fact. But wouldn't it be cool if you could, right? So it's sort of that kind of thinking that we're looking at. Is there a set of language features there that can solve those kinds of looser coupling combination of types? And we're starting to look at that. So it's on the roadmap. It's in that working set that I showed you, that shows up in there. I don't expect this to make it into C#10. It will require significant runtime work and so on, but it's exactly that kind of big feature that we need to get going on. If we can't only start when in the release where we think it will make it into, because it takes more than a year to get it right. So so we're starting now, and hopefully we got a good thing to address that in release 2.
Yeah, I'm looking forward.
Or we figure out why we have to give up on it.
Yeah. Hopefully
Back
not.
Sorry. Back at 9:48, and I don't know if this has been answered or not. Richard Howells asked about. I came across an attribute the other day that purported to pass in as a string the expression used by a caller for a parameter. He then clarifies a little bit further down, saying the attribute I referred to above is caller argument expression, but it's at 9:48. Richard Howells.
Caller. What is it? Yeah, that is the thing that I believe we didn't get to it in C#9, but we totally want to, and we just didn't make it there. So that's where the string containing the expression that was used as the argument comes in as an additional argument. In the same way, if you've seen caller name attribute and those things, which again is useful for debugging, then the method getting called has access to the source code of its argument and can use that in error messages and so on.
Cool. I think Richard actually left, but hopefully he'll be able to catch up on YouTube.
No, I didn't leave. I'm here.
Oh, no, you are. Good. Oh, I don't know
there?
why you didn't come up in my list of people there, but it seems to be a little bit out of sequence.
All right, Peter, I'm just stealth listening, right?
Well, that's fair. Good. Well, I'm glad you're still here to be able to. Sorry, I missed your question there. I must have skipped over it. So glad we were able to answer that for you as well. I mean, obviously, I'm now conscious it's 10 o'clock. We've still got 35 people watching, and I'm still fine to hang on, but I don't want to force people to have to do that. And I also know that Mads is going to be a busy guy, so I don't want to have to force Mads to hang on either. So again, thank you very much, Mads. At that point,
well, thank you guys. This has been extremely fun. Thanks so much.
It's been really good. We really appreciate you coming along, and again, thank you to everybody else that's come along.
Hey, you're welcome back anytime, Mads. Please come back.
Sounds good. Yeah, as I said, I hope I can make it in person at one point. That would be great.
That would be great.
We'll call dibs.
Yeah. Applause for Mads.
Yeah, absolutely. Thank you.
Thank you, guys.
So I mean, yeah, we can wrap it up now. I'm completely open to staying on longer. It's entirely up to Mads at this point as the VIP in the room.
That's probably good. I mean, it looks like we got through the last bulk of questions there. That's probably a good time to call it quits. I can't remember the last time there were 3 hours worth of questions. It's been great. So
yeah, we really appreciate it. It has been, and the questions from everybody have been really good as well. And I'm always amazed at how much I don't know when people start asking really intelligent questions about stuff that I don't even understand. So, and a lot of that, as I say, has been tonight. So it's really good to see that. So yeah, thank you again, and awesome. We'll see you all in a couple of months' time almost. So have a fantastic Christmas, and obviously it's been Thanksgiving, so that's been and gone. But it's been great to see you all this year, and I know it's been different with it being all virtual and everything, but I think it's worked out quite well, and we've transitioned quite well. So we'll carry on this way for now in the new year and see where we go. Don't forget
the challenge.
Yes, exactly. Like Jess just says, get involved in that. And see, you never know, you might win one of the amazing prizes that are on offer there. So thanks again, and we'll see you all soon.
See ya.
See ya.
Bye all.